and also expansion of port capacity, which in turn would increase the need for bulk carriers. And of course, again, large ships with a deep draft. So the development of the PPU, in 2005 we started with a off-the-shelf product, which had AIS and GPS, separate units, integrated into a notebook. It was an off-the-shelf product. It was very heavy to carry on board, and pilots complained about this. It also used time to install it, and well, it was not fully adapted to the needs of the River Elbe. With the arrival of the pilot plugs, this was the bandwagon to jump on, and so we conceived the idea and the concept to have a notebook with a tailored software to be plugged to this pilot plug, and also carry on board bathymetric data, and this data to be overlaid over a electronic nautical chart. And that's the main point of the presentation, how we arrived at this solution. Well, there are requirements regarding the hardware, basic parameters. It should be customary components, should be state-of-the-art, it should be high reliability components, and of course, cost efficiency is an important factor too. The user requirements were as low as possible in regard to weight. Maximum battery capacity, the passage takes up to 6 hours. High resolution, simple, intuitive handling, of course compatible with the pilot plug, compatible with external sensors, and of course external memory. Regarding the application, the user requirements were to have ENC-like chart display, position the own ship in the display, display updated morphology, display AIS information, intuitively operates the system, and well, simple menu navigation, unmistakable colors for day and night operation, short start up, and of course the replay function. So we came up with a 4-step program. Step 1, integration of updated soundings. We call this BENC, Bathymetric Electronic Nautical Chart. Second step, integration of real-time tide gauge information. Third step, integration of underkeel clearance management system. And fourth step, integration of logistic traffic system. Now we have arrived with the first step, and this is what I'm going to show over here. So the evolution of this BENC, on your left-hand side you can see the paper chart, and to the right-hand side the ENC. And the first decision was taken, we want to have a vector chart, vector-oriented ENC. So we went to the charts delivered by the DSH, our National Hydrographic Office, and this is how it looks like in some more detail. Over here you can see some stretches of the River Elbe. As you can see, it's highly populated with shore installations. So this was a PPU display we bought off the shelf, and what you see is the bathymetric data is missing over here. It shows a little bit of detail regarding the shore and the ports and so forth, and of course the position of the ship, but the bathymetry is missing. So how did we merge these two aspects? Sometimes it takes long. Aha, here we are. The first approach was to look at what the dredging folks have in store in the water-based dredging bureaus of the local offices. And this looks like this. And it's quite detailed because the goal for having these maps is a different one. And on the other hand, you see the 2B depth over here in the ENC. So the conclusion was we need to redesign, for the purpose of this bathymetric ENC, the dredging charts and bring them into the S57 environment and create a digital ground model. Of course, in a cell-oriented way for the River Elbe. And the first step was this one. So we did an overlay, but as you can see, it's much more too much detail. It's a clutter of information actually, which is not useful. So this was just a pre-BENC sounding plan, and it's not suitable for that PPU idea. So we diluted it a little bit and created this one, and still this didn't found favor with the pilots. It is still too much information. And eventually it looked like this. So this gave sufficient information on the actual depth contours, but not too much. So this is a result for the bathymetric BNC, or BENC. Over here you see the ordinary ENC, and over here that's a result with the overlay of the bathymetric data. And the pilot now can see clearly the true depth of the water, and it's of course up to date. This is how it looks when you zoom in, and for instance here you have the lock situation where the Kiel Canal merges into the River Elbe. So we had trial runs. The intention was to test the whole setup, and of course not only the PPU as such, but also the data converting process, the data integration and updating. After successful trial runs, more PPU units will be installed to be of use when navigating deep draft or extraordinary large vessels. The next step would be to start the PPU step 2, as indicated earlier. And this would allow for tidal information to be put into the same BENC, and it would allow to show the tidal window where particularly deep draft vessels would allow to safely operate when approaching Hamburg or leaving Hamburg. So here's an example how it would look like. You see the tidal window, that's the area where it's safe to navigate on the tidal wave for this ship, and it's of course calculated for this individual ship. And that's of course the current position of the own ship. So that's the plan, and it uses the bathymetric data and draws a window around it. So it's just another tool. It doesn't replace the other tasks or tools of the pilot, but it is greatly appreciated by pilots along the river. And so this is now a great improvement, and we are very much looking forward to do the next steps in real life, which means to include the tidal window and of course have online update of the tidal gauge. Thank you very much indeed for your attention, and if you have any further questions, please format a paper, the question leaflets to me. I will forward them to Captain Seidel, and he will certainly answer your questions. Thank you very much indeed.